Thank you, Wilher. Hi, good day, everyone. As Wilher said, my name is Harold Haraldson. I'm an AIMMS optimization specialist. And today we're going to be talking about how to use our own Excel datasets effectively in the AIMMS WebUI. So on our today's agenda, we will start by talking a little bit about the optimization applications and the end-user data and some hurdles we hit when we started using WebUI on Pro using Excel. Then I'll go talk about the new AIMMS Excel library that we just launched earlier this year. And then I'll combine it with two widgets that we also introduced this year in the WebUI, so the upload widget and download widget. So why do we want to use repeated end-user data in our application? Well, as a developer, we always want to get a return on our investment, and therefore we want to create applications that we can use repeatedly. To do so, we want to enable the end user to upload new relevant data every time he runs the optimization application. And the end user, he might be looking at different days, locations, scenarios, offers, option and an option chain, anything he wants to do a research on and get a qualifying decision on. These end users data, they can be in many form or shape. That can be a centralized database. The end user might want to manually type in his new data, but he can also have them on an Excel file. And today we will be focusing on Excel workbook and how to get your data of your Excel workbook to your application model. Sorry, to your optimization application. So if we take a look at the environment when we have the end user running an AIMMS application on our Pro. When the end user fires up his Pro application using the Windows UI, he opens a client session on his own machine, so he will start a deployment version of AIMMS on his machine, loading up his application. At the same time, a server session is launched and is running on the Pro server. That gives the benefit that the end user is now running two sessions, one on his machine and a separate one on the AIMMS Pro server, and that allows him to have access to all different software components on both the end user PC and the AIMMS Pro server. Usually, in this case, if the end user has an Excel file with data, he would simply load the data on the client session. The AIMMS model will do any pre-processing to the data and then send all of the data to the Pro server, where we will execute the solve session and do all the heavy calculations. Now, when we introduced the WebUI, we had a little bit different format on it. With a WebUI running on AIMMS Pro, we have both the client session and the server session running on the Pro server. And on the end user machine, we will only have a web browser showing a web page. So this broadened the availability for an AIMMS application widely, because now we no longer needed a Windows PC that would run AIMMS. Only we needed any network connected device with a web browser. The idea of getting the data, we also added the upload and download widget, so we could get data across from the end user machine to the AIMMS Pro server. But then we had the limitation that because we had no actual AIMMS session running on the end user machine, the application could only have access to applications that were available to the Pro server. And that gave us a small problem when running with Excel, because Excel is not a server software by default. So even if you had it installed on the server, it would probably not run with our old spreadsheet statements. Unfortunately, we learned this the hard way, but nevertheless, we started looking for a problem and for a solution. And the solution was that we created a new AIMMS Excel library. What's unique about the new AIMMS Excel library that it does not need Excel to read or write data to an Excel file. So instead, AIMMS digs directly into the file itself without involving the software Excel. That gave us the availability that now we can run, work with Excel files on any environments, even if Excel either is not installed or cannot be installed on that particular machine. We decided to add the Excel library as a system library to AIMMS, so it is available with any recent versions of AIMMS. So just by simply adding the library and adding a system library, we have access to all of those new statements. What we furthermore discovered in the development net is we saw an increased speed in reading and writing data. And that is because now, as I said before, we don't involve Excel anymore. So we don't have to wait for our machine to fire up Excel in the background and run an extra software in the background. Instead, we just go simply into the file itself and work with it. And that left us out with some added nuance that we could skip. So we saw an increase in speed. However, we have some drawbacks with it. One is that formula results are not updated. And then I'm talking about formulas that we have on our Excel sheet. For the same reason that we're not running Excel in the background, any data that is calculated by formulas is not updated correctly. Another one is another issue is that we with specialized edited data, such as true and false or calendar data, we still have difficulties running that with AIMMS, but for most of them we have a workaround, so they do not cause us a big issue. So in the Excel library, we included the most common functionalities that are used from our spreadsheet statement. So if you adopt the new library, you should not miss any important function that you were using before from the spreadsheet statements. We also added numerous of new methods on how to manage your workbook, as well as multiple tools on how you can control it. Our AIMMS Excel library has a prefix, so every time you want to call a statement, you simply call the AXLL prefix, and that gives you access to all of the new statements in the library. If we look at the setup of the library, we can see that the user's statements are divided into 5 groups. So first we have the Workbook Management, we have Utilities, we have Scalar Read and Write, we have Sets Read and Write, and Multidimensional Data. How the new AIMMS Excel library is set up is if you open the attribute of each statement you want to use, so for example we are looking at the right table, we have in the comment section information on how to use this particular statement. And if we take a little closer look at it, we can see that we have each argument very thoroughly explained, what options we have, and then we also have an example on how we would use this statement in our application. So the accessibility to information on how to use a new AIMMS Excel library is very good, and it is included in your installation of AIMMS. If we take a little closer look at each of the section and just go through them one by one. The first one is the Workbook Management. The Workbook Management section gives us statements to work with the Excel workbook and the Excel sheets of the file. So we can create, we can select, open and close the workbook. Similar with the workbook sheet, so we can create a sheet, we can select the sheet and delete one. We can also check if the workbook is open and check if any particular sheet exists in the workbook we're working with. The arguments for each of these statements are either the workbook we want to work with or the sheet that we want to work with. The utility section contains interaction-related statements, especially with the sheets. So with a sheet, we can either construct or clear a range in the sheet, so we can range of cells and name it, so we can later on refer to it in the Excel file. We can simply clear out the full content of a whole sheet. As well, we can collect all of the sheet names that are in the particular workbook we're working with. In that case, we would read them all into a set. The third section is for scalar variables. So we can both read and write single value elements either from the workbook or from our application. And in this case, we can only connect one individual cell to a scalar parameter or a specific element in our AIMMS application. Going into a little bit more complex features of our workbook, we can also read and write sets. The read and write set statements only work with a one-dimensional list of data from the Excel file and a set identifier in AIMMS. When reading in data from the Excel from an Excel sheet to our AIMMS model, we have several options. One of them is that if we are reading into a subset and the elements that we are reading does not exist in the parent set, we have the option if you would like to extend the parent set with the new elements that we are reading. As well, when writing a set to an Excel workbook, we also have some control options. One of them is if we want to merge the current data with the elements or completely replace them. The multi-dimensional data section offers us to work with two types of tables in Excel. One of them is a regular multi-dimensional table that works with two or more dimensional identifiers from AIMMS. The second one is a list table, or more as we would refer to it as a composite table. With that table, we can work with from a one-dimensional parameter or an identifier and up. So the more of the options we have in the multidimensional data is that we can decide if we want to either completely write a completely new data, if we want to fill into a current table that we have in our Excel sheet. We also have something called quick write. So then simply we just select the first cell in the Excel file we want to write to, and then which parameter, and AIMMS will write out the content. We can control how we would like to write 0. So do we want it as an empty space, or do we want the actual value 0 to be written? How to write table is somewhat complicated. So I'm going to dig down a little bit deeper into how we work with each one. So if we start with the list table, where we have reading and writing options, we always have to define our row header range and the data range. And if we look at the Excel sheet to the right, we can see respectively how each range is defined. So the row data range would have to will represent the indexes of the parameters. So this would be the domain and the sets that the parameter is declared on, and then we have the data range. If you look to the table, the multidimensional table in the AIMMS Excel library, we add one more component that we have to define, which is the column header range. And if we look again at the Excel sheet, we can see that we have the row header range, we have the column header range, and then we have the data range. As I said before, the table is for two-dimensional identifiers or more, so that meaning that we will have to have at least one index in the row header range and one in the column range to work with the table. How we set up the size and dimension of the table is that we count the columns in the row header range. So in the example to the right, we have A and B, so 1 and 2 columns, and the rows in the row header range. So we would count 1, 2, 3, 4 rows in the column header range, combine it with the columns in the row range, and that gives us the number of 6. That means that the identifier we would like to write to this table would need to be 6-dimensional. And if we look closer at the example, I have my parameter. We have 6 indices, and how they would arrange in the table is we go from left to right and top to bottom, beginning with the row header range. So the column A would have the index I, B would have J, and then rows 1 to 4 would take K, L, M, N. So this is how we would arrange and fill out our table in Excel. If we now move to AIMMS, where we would actually be creating one of those read and write statements. If we start looking at the AIMMS Excel library that I showed you before, we have the AIMMS library section. We have the AIMMS Excel library. We open the public section, which are all of the identifiers that we can use. In the Workbook Management, we have all different statements that we can use to control and command our Excel library. And in the sample that we are looking at, I'm going to start by reading data from an Excel file. So I start by opening the workbook. So these are similar steps we had to take with the spreadsheet library. So we first have to open a workbook and let AIMMS know which which Excel workbook we're working with. Then we select the active sheet, because as you can see in the Excel file on the right, we have 2 sheets, population and W data. So we select which sheet we want to be working with, and then we use the read list statement. So first we indicate into which AIMMS identifier we want to read the data into. Then I define the row header range, which is A1 to A8, and then I have the corresponding data in B1 to B8, which we want to read in. Then we have 2 more arguments, mode for unknown elements, and if we want to merge with existing data. If we open the attribute list, we can see we can quickly get information on how to work with these work with these arguments, and And I have set for mode for unknown elements is 1, so that I will add new elements if they're not already in the set. Merge with existing data, I have it set to 0, so that means that any current data in that identifier I will delete and override it. If I would have the selection 1, I would select the merge option. Now that I've set up how to read in the list, I will move to my next sheet. So that means I will select the other sheet in my Excel library. Now I have a three-dimensional identifier, and I want to read in weather data for a list of European cities, the annual rainfall and high and low temperature for each month. So I start by declaring my my row header, so which is A2 to B25. So that's this corresponding area, and then I work with my column header range, which is C1 all the way to N1. And as you can see how the indexes are lined up, so we have C for cities, we have D for data, and M for months. So again, the read table and the table identifiers to work from left to right, top to bottom. So I start on the C, move over to the D index, and then I work from top to bottom on the column header range and work with the C. Again, I want to add any new elements that I might read in to my sets, and I merge and I decide not to merge the data, but replace it. At the end of the procedure, we will close all we will close the workbook that we are working with. So to see it in action, so we can now see that both my population and weather data is empty. So if I run this procedure, I can see now that I have the data read in from the application. Working with similar statements to write the data. Because in this case, I will be creating a new workbook file, which I'm going to name output. I want to start by checking if that current file already exists. And if it exists, I want to delete it because that means that probably a workbook with the same name is existing at the same location, and it probably has an old data, so I want to start by deleting it. My first statement is that I want to create a new workbook, and then I give it a file name, and then I create the first sheet in the workbook as well. I want to take data from the identifier that we just read in, and I basically want to write it to the same format to my newly created workbook. When I write data, I have two more options that we haven't seen before. So that is the allow range overflow and write 0. So the allow range overflow allows me to extend the range that I declare. So for my Excel workbook, I declare a certain range. If my identifier contains more data or exceeds the range that I define, then I have the option if I want to continue and expand the range automatically, or if I want to keep stay within the range I defined in the header range and the data range. Then we have the option to write if we want to write 0 or not. So the indicator 0 means that we will leave any values with 0 blank, so we will not read it to our spreadsheet file. with the option 1, we will write write out 0. And then again in the end, when we're finished, we will close the workbook. So if I open my if I open my project folder, I can see I still have an output file, so I'm going to go and start ahead and delete it, just so you can see that a new file appears. And now if I run my procedure, it will run through, create a new workbook, write the data, and you can see now I have my new output file with my weather data, and the first sheet name is sheet 1. So moving back to our presentation, now I want to take you through our 2 new widgets, the upload and download widgets, and how we would set them up and run them. So the AIMMS upload widgets enables our end users to upload any file in any format to our AIMMS application. What the widget simply does is accept the files, and then it will run a procedure that you will write, and then to decide how you want to process the file. So if you look at a sample sequence on how the whole process looks like, that the AIMMS user will select a file in the AIMMS upload widgets from his computer that he wants to upload, and will initiate the upload sequence. Then the upload procedure is executed, and what happens is that on the back end, AIMMS will save the file in either a project folder or a pro temporary folder with a unique ID. It will give some feedback back to the end user, so either we had a successful upload or we had any issues. Then we will initiate a procedure on how we want to process the file. So do you want to read in data? Do you want to stash it at some specific location, or whatever we want to do with it? And then in the end, we recommend that you will delete that file from the system, so you won't pile up large data files on your backend, which will take up valuable space and process power. So moving to the upload procedure, this is how it would usually look like. So we will give the end user feedback, the status code OK. We could also have some check to see if the file exists or not. We will give him some description on how it, on what took place. We will locate our file, so with the input file name, which is a string parameter containing the location of the file, calling the statement WebUI get IO file path, and then the file name. We are able to locate and refer to the uploaded file. Our next step would be to execute a procedure on how to process the file. In this case, we will run our read Excel file procedure that I just showed you in our demo before. So reading in all of the data from the document, and then in the end we will delete the Excel file from our system. The 3 arguments that we work with in the procedure, I want to draw your attention a little bit to them as well. So we have the upload file name, which has to be a string parameter, and that is an indication to the actual file that we just uploaded. The upload file name can have any name you prefer is the best fitted for your application. However, the status code and the status description is a value parameter and a string parameter, and they have to have this exact naming convention for the upload widget to work properly. So they have to have the status code and status description respectively assigned. So now I want to show you how the upload widget actually works. So I have uploaded a small demo to my Pro environment. So I will start by, oops, went to sleep. So what I will do is that I will start my my WebUI application and try to read in a file I have on my PC. So let's just fire up my Pro again. So now I've launched my WebUI, and we go to the upload file section. So here we see I have two empty tables, one which I want to display the population data, the other one where I want to display the weather data. So I start, and here we have the upload widget with the assigned upload procedure to run once we run the widget. So I start by button, selecting a pre-formatted Excel file to open and press start. So now AIMMS has uploaded my file, read the data, and you can see the data appearing in the table. Now let's move to the download widget. So in some cases you might want your end user to be able to extract either a report or data from your AIMMS application to use either for further processing in a different software, or for reporting or analysis use. For that purpose, we created the download widget. The download widget will actually prepare a file for you on the back end and then make it available for the end user to download. So once the download is initialized, the AIMMS will start preparing the file, create or collect the file, make it available to the end user, which will then download it on his computer or on his device. I want to make one remark that at the end of this procedure, we do not want to delete the file, because the procedure will finish its run before the end user will download the file. So we will in that case, we would delete the file before the end user would have the opportunity to download it. So, but if we take a look at the procedure that is executed with the download widget, you can see we start creating a file, and this is the write file that we just demoed before as well. So we will create an output file, write some data to it, and make it available to AIMMS. Then we make sure that we have the location of the file. So using again the get file path for the temporary folder, and that works both on your desktop environment as on a Pro environment. Then we let AIMMS know about the file, that specific file location, and then we check if the file is ready and is available. And if it is ready and available, we will give the end user the notification. But if we have some issue creating the file, the end user will be prompted an error. Again, the three arguments, the first one, the file location, status code and status description have to be available for the download widget to work properly. The file location can have we have flexible naming, but the status code and status description has to be the exact those two exact naming conventions. And now if we move back to our AIMMS WebUI, we can see how the download widget actually works. Well, this is what we get with live demos. Let's start the whole sequence again. I want to launch my application. I'm going to have to, well, I have data, which is good. So yeah, oh, it's working properly. So this is how the download widget looks like. And if you go into the setting menu, you can see that we do call our download procedure. And we simply press start. AIMMS will prepare my file, and you can see here in the bottom that it is already downloaded and is available on my computer. And now I can open it in AIMMS. So that concludes our topic in this webinar. If you take a look a little bit on what we've covered, so we did cover the process on how we interact with Excel workbook files in an AIMMS Pro environment using our new Excel library, and how we have now bypassed the hurdle of not being able to run our spreadsheet statements with Excel on a server system. Furthermore, we demoed on how you would use the WebUI to actually get your Excel file to the Pro server, and then close the loop by demonstrating and giving you information on how you can create an Excel file on your Pro system using the using AIMMS WebUI and downloading the workbook file or any report back to the end user's machine. Before we go into questions, if there are any, I want to draw your attention to our next webinar in our series, and that would be on how to use AIMMS for Monte Carlo simulation, and will be presented by my colleague Dian Chang. Please join us on November 16th, 2016, and we have one broadcast, either 5 p.m. in Europe, 11 a.m. East Coast US, and 11 a.m. East Coast US, and 8 a.m. Pacific Standard Time. So that's West Coast.